All right, welcome. In this video, we're going to be working some improper integrals, and we're going to be very careful on how we're justifying our answer, right? So for the first set of 8, this is like find the value of the integral or show that it diverges, kind of implicitly throughout this whole homework, justify your answer, because that's a big deal for AP Calculus. So the first one is 1 over x cubed dx. Starts off with a pretty straightforward one. We see that it's going to be an improper integral because of that infinite bound of integration. So we start off thinking, probably best off writing that as x to the negative 3 to remind ourselves to use the power rule. And remember what I said in class, we need to have at least 2 limits in our statement. Okay, so this is going to be the limit of an integral. So it's the limit as the upper bound goes towards infinity. Right? But everything else the same. Okay, I recommend off to the side doing scratch work for the antiderivative because it's just, I have graded these on pre-response, and of all the BC topics, like this is the one that they're the most picky on. So I'm going to say, okay, antiderivative of x to the negative 3 dx equals add 1 to the power, divide by the new power, plus c. Okay, so I've got that over there. And I'm going to say, okay, well, if I do negative 1/2 x to the negative 2 from 4 to b, that's going to be, okay, negative 1 over 2b squared minus negative 1 over 2 times 4 squared. Okay, and I'm just saying that's just scratch work off to the side. And then I'm going to say, okay, that's what I got when I kind of ran the integral. I'm going to say, okay, this is still the limit as b approaches infinity of negative 1 over 2b squared plus 1 over 32. Okay, as b approaches infinity, that first fraction is going to go 0, and this is going to be 1 over 32. All right, number 2. This one's improper because of a vertical asymptote. We don't see that infinity in the bounds of integration, but we do see that 0. And if you think about what would happen at x equals 0, we'd be dividing by 0, and that's not good. Okay, so over here, number 2, this is the limit as the lower bound approaches 0, really from the positive side, of the integral from a to 9 of 3x to the negative 4/3 dx. Off to the side, I'm going to do the antiderivative step, or you could just, call it the integral from a to 9. I'm just thinking about the antiderivative of 3x to the negative 4/3. I was getting ahead of myself. That's going to equal add 1 to the power, so x to the negative 1/3, divide by negative 1/3, so it's like multiplying by negative 3, okay? Okay, and then, okay, if I'm doing from, a to 9, I'm going to say that's negative 9 over the cubed root of x. And maybe, because that's just scratch work anyway. Okay, so this over here is equal to the limit as a approaches 0 from the positive side of, okay, plug in 9, negative 9 over the cubed root of 9 minus negative 9 over the cubed root of a. That's a is approaching 0, and I'm dividing by a. That's not good. Okay, that's what is going to cause us to have divergence with that and a few other things. Okay, I'm going to say that limit does not exist, and I'm going to say, okay, that's how I know this integral diverges. All right, number 3, the integral from 10 to 100, or 10 to infinity of 100 divided by x squared. Okay, so that'll be the limit as the upper bound approaches infinity of the integral from 10 to b of 100x to the negative 2 dx. Okay, now we could just kind of keep writing b approaches infinity and then say, okay, antiderivative for x to the negative 2 with respect to x is going to be negative x to the negative 1. Okay, from 10 to b. Okay, but I find that kind of unlikely, so that's why I'm suggesting that we go off to the side and do our scratch work there. With these, because we're thinking about limits, I find it really useful to go back to a fraction from the negative exponent after you anti-differentiate. So this would be negative 100 over x, okay, where x is b, minus negative 100 over 10. So, okay, b goes infinity, that first fraction goes 0, that's going to be plus 10. Right, now number 4, 1 over the square root of x times 2 minus square root of x from 0 to 1. Okay, x equals 0 is going to be the issue. Okay, that thing would have vertical asymptotes at x equals 0 and at x equals 2. Okay, and I feel like... No, the domain is just going to be positive x's. Okay, so it's the lower bound that's approaching 0. And we're integrating up to 1. Now with this, this one's going to require a substitution. And I'm really recommending for once that you can see require UDU, that you go and do that off to the side, just really to avoid the possible linkage errors. There are many with the changed bounds and things. So what I would do is I would say, all right, 1 over, because I see it has to do with that 1/2 x to the negative 1/2 thing. So I think what I'm going to say is I've got an x to the negative 1/2 and a 2 minus square root x to the negative first power. That's how I would say that one. And I'm gonna then say u equals 2 minus the square root of x. So du is negative 1/2 x to the negative 1/2. Of course, I just have 1x to the negative 1/2, so that's going to be negative 2 du. So now I'm integrating negative 2 times u to the negative 1 du. So that's negative 2 log absolute value of u plus c. Now I know that u was equal to 2 minus the square root of x, so I'm going to plug that one back in, just get myself a full-blown absolute antiderivative, which is 2 minus square root x. Okay. So over here, I'm going to say this is the limit as a approaches 0 from the positive side of, okay, negative 2 natural log of the absolute value of 2 minus square root x from a to 1. All right, and then that's going to equal, I'm not just immediately seeing it, so I'm going to just plug in 1, so negative 2 times the natural log of 1 minus negative 2 times the natural log of 2 minus the square root of a. And as a approaches 0, that will be 2 natural log of 2. Okay, number 5. This one also is going to require u substitution. Right? We see that product with the 2 to the x to the 5. So I'm going to first write it as a limit. The lower bound is approaching negative infinity. Upper bound is 1. X to the 4, 2 to the x to the 5. This one's kind of wild, but definitely in bounds. So u equals x to the 5 du is 5x to the 4. 1x to the 4 is equal to 1/5 of du. Okay, now meaning I'm anti-differentiating 1/5 of 2 to the u du. Okay. Remember, antiderivative for 2 to the u with respect to u would be 2 to the u divided by natural log of 2. That's a formula we just need to know. Now we've also got a 1/5 there. Okay, so that's what it is. And then we're going to go back to u, and so that's 1/5 log 2 times 2 to the x to the 5th. All right, so, and I think since, really the only x in there is right there, I think we can envision plugging in 1 and then plugging in a and subtracting those and saving ourselves one line. Okay, so as a approaches negative infinity, we're going to plug in 1 because that's the upper bound. And maybe, so I don't have to write it twice, I'll just factor out the 1/5 log 2. 2 to the 1 to the 5th minus 2 to the a to the 5th. As a approaches negative infinity, so does a to the 5th. And I'm taking 2 to a more and more negative power. That's like 1/2 to a more and more positive power. That's going to go 0. And so I'm going to have 2/5 natural log 2. All right, and that one's pretty intense, but so that's how these improper integrals are. They're definitely one of the more challenging topics in AP calculus. All right, 8x over x squared minus 1 squared. All right, so the issue with this one isn't going to be the 0, it's going to be the 1, right? Because at x equals 0, I just have 0/1, and there's nothing wrong with that. So it's going to be the limit as b approaches 1 from below of the integral from 0 to b, 8x over x squared minus 1 squared. Once again, use substitution. So I'm going to say, I'm thinking u equals x squared minus 1, then du will be 2x, and we can work with that 8x. 4 du would equal 8x dx. So I'm going to be having 4 times the integral of 1/u squared with respect to u. That's going to be negative 4u to the negative 1. So that would be negative 4 over x squared minus 1 plus c. All right, and then, all right, yeah, I'm pretty sure that seems right. And yeah, based on what I thought was going to happen with this one. And so that's the limit as b approaches 1 from the negative side of negative 4 over, plug in b for x, so b squared minus 1 minus negative 4 over x is 0, so 0 squared minus 1. Okay, and I'm seeing as b approaches 1, I'm getting close to dividing by 0, and I don't have anything to like cancel or anything. I think I do like L'Hopital's rule or anything. So this one's bad news. This limit does not exist, and I say that the integral diverges. Okay, number 7. And just give me the limit as the upper bound approaches infinity. Okay, 12 times x plus 7 to the negative 3 halves. All right, and we're going to anti-differentiate off to the side. It's been a while since we had one that didn't require a u substitution. That's going to be 12 times x plus 7. I'm going to add 1 to the power first, and then worry about the new power. Okay, multiply by -2. So negative 24 times x plus 7 to the -1/2 plus c. And that's going to equal the limit as b approaches infinity of plug in b first, and the -1/2 power, it's 1 over the square root of x plus 7. So now I'm thinking about plugging in b, so -24 over the square root of b plus 7 minus -24 over square root of 2 plus 7. As b approaches infinity, the fraction on the left is going to go 0. 24 over 3, that will be 8. All right, and then number 8. I can't remember if this one's, I feel like, it looks like it's going to diverge to me, but I'm not certain. The issue with this one is x equals 0, because I plug in 0, I get 1 over 1 minus 1. So it's the limit as the lower bound goes towards 0 of the integral up to the natural log of 3 of e to the x over e to the x minus 1. And this one will require a u substitution. So I'm saying u equals e to the x minus 1 du equals e to the x dx. I lost my dx, but it'll be all right. That's exactly what I have. So this is really just 1 over u du. Right, and so this would be natural log of the absolute value of e to the x minus 1 plus c. Okay, and no, this is still trying to get me to take the natural log of 0, and that's still no good. Okay, just like I was trying to divide by 0 earlier. Okay, yeah, I think this one's going to non-exist, but okay, when I plug in x equals natural log 3, log of e to the log 3, that's 3 minus 1 would be 2, minus natural log e to the a minus 1. Okay, and because a is approaching 0, and that would be like 1 minus 1 there, I would be getting closer and closer to taking the natural log of 0, which does not exist, so that's not equal to anything. This diverges because this limit fails to exist. Okay, that was number 8, and that was a good, kind of set of drill problems. All right, yeah, and past this, I've got some that have some graphs and kind of modeled off of free response questions that I have seen. So find the area of W, and W is kind of like an unbounded region on the right, and the left side is x equals 3, and bounded by the graph of y equals 1 over x squared. So the area of W, that would be the integral from 3 to infinity of 1 over x squared dx. So I need to write that as a limit. I need 2 limits. I need a limit of an integral, and then I'm going to need at least one more limit after that. Okay, so this is going to be the limit as b approaches infinity, integral from 3 to b of x to the -2 dx. Okay. Antiderivative of x to the -2 is -x to the -1. Okay, and that's -1 over x. So plug in b, -1 over b minus -1 over 3. And b is still approaching infinity, and -1 over b will approach 0, and so this is 1/3. Okay, and then find the volume of the solid formed by rotating W around the x-axis. So, got that here, that's my x-axis. Okay, that looks good enough. All right, so thinking is my radius will be reaching from the axis of rotation to the far edge, just 1 over x squared. So radius equals x to the negative 2. And then volume is going to be the integral of pi radius squared. Rotating around the x-axis dx. Right? And w goes from 3 to infinity. Okay, now I'm going to actually simplify that first. So 3 to infinity of x to the negative 2 squared would be x to the negative 4 dx. All right, so now that'll be limit as the upper bound approaches infinity of the integral. Maybe I'll just put the pi back in. All right. Antiderivative for x to the negative 4 is going to be negative 1/3 x to the negative 3. And I might call that negative 1 over 3x cubed. Okay, got my first limit, need my second limit. Be negative 1 over 3b cubed minus negative 1 over 3 times 3 cubed, so that'll be 3 to the 4. Okay, so that's going to be, first fraction goes 0, that'll be 1 over 81. I totally lost the pi, though. Okay, so I'll just factor that out like that, I suppose. And say, okay, I had 1 over 81, so it'd be pi over 81. Or you could write pi over 3 to the 4th power. Right, next we've got just some function, f of x equals negative 8 over x squared plus 6x plus 5. And what I'm noticing about this one is this one looks like one of those functions we dealt with last time where we could factor the denominator and split it up into partial fractions. But the first question asks us for the slope of the tangent line to the graph of f at x equals 0, so that's just going to be like find the derivative. And that doesn't really have anything to do with partial fractions, so we're just going to say we can rewrite f of x in a way that's more advantageous to take the derivative. So that would be negative 8 times x plus 5, x plus 1. No, that's not what I need. I need to just write it as a negative power. That'll be in the next part where I want to write x plus 5, x plus 1. Okay, now I'm going to take the derivative, I guess using the chain rule. So start by doing negative 1 times negative 8. Leave the inside the same, subtract 1 for the power. And multiply by the derivative of the inside for the chain rule. All right, at x equals 0, 8 times 5 to the negative 2 times 6. So that's going to be 48 over 25. That was a good one. I like that one. Right, find the value of the integral from 0 to infinity of f of x dx, or show that it diverges. Okay, so these are a little tricky when you have to use partial fractions, but they do oftentimes work out because they're second degree in the denominator. If it's bigger on bottom by 2 and we're going to infinity, we got a good chance. So what's happening? F of x dx. I need to do the partial fraction thing, and I was thinking about doing that up here. Yeah, I'm going to do that. All right, so I can just go over here and say that equals a over, let's see, x plus 5 plus b over x plus 1. Okay. multiply both sides by both denominators, and I get negative a equals a multiplied by x plus 1 plus b multiplied by x plus 5. Okay, now when x equals negative 1, I'm going to have negative 8 equaling 0a and 4b. So b is 2. And then when x equals negative 4, no, not negative 4, negative 5. Negative 8 equals negative 4a, which means a is positive 2 also. Wait a second. Oh, I see it. I just have a pretty clear algebra error there. So b equals negative 2. And now, all right, so let's see. A was 2, b was negative 2. So 2 of these minus 2 of those. All right, and now I'm going to use that to run the integral that they've requested. So the integral from 0 to infinity of f of x dx equals, I'm going to write the limit, and I'll just keep it simple, not actually copy it in. I'm just going to call it f. Okay, we need a limit of an integral. I'm going to do the antiderivative step off to the side. 2 over x plus 5 minus 2 over x plus 1. I am going to combine those so that I can take the limit more easily and I can actually see what's going on here. I've done something wrong. Yeah, that's supposed to be a 5. So x plus 5 over x plus 1. Okay. So now I'm ready to go. Let's see. All right. I'm going to be considering what happens when b approaches infinity. Okay, b is the upper bound, so I'm going to start with that. 2 log of b plus 5 over b minus 1. So as b approaches infinity, this fraction is going to approach 1 because, you know, I could do L'Hopital's rule on it. I'm just thinking about the fraction. But I'm getting closer to taking the log of 1, which is going to end up being 0. Okay, so this one's going to converge. Minus 2 log, I guess unless something bad happens here with the inside of the log when I plug in 0, but I don't think that's going to happen. Okay, 0 plus 5 over 0 minus 1, so that's the log of the absolute value of negative 5, which is not a problem because we're taking the absolute value. And so, all right, that's going to equal 2 times the natural log of 1 minus 2 times the natural log of 5. So negative 2 natural log of 5. Okay, that's an interesting one, but you know, I can see that that is probably a negative function on, yeah, a positive interval. Yeah. Okay, yeah. Okay, so I guess it would make sense that I would get a negative value. Okay. Now, kind of another area volume type question is, we've got g is 12 over x plus 3, and all the rest of that stuff. Okay, area of the shaded region. Okay, so that's going to be top minus bottom from 0 to 3. Okay, so if I was going to make a replica, okay, top minus bottom is going to be f of x minus g of x. So the integral from 0 to 3 of f of x minus g of x. Okay, the integral from 0 to 3 of f is going to be 10. So that would be 10 minus 12 natural logs of x plus 3, or I guess the net change in that from 0 to 3. Okay, and this is not an improper integral, so I don't need limits or anything. I felt like I was not showing enough work here, but that was just because this was not an improper integral. So I've got 10 minus 12 log 6 minus 12 log 3. Okay, and if you want to stop there, that's perfectly fine. But if you wanted to combine those, I guess we could factor out the 12. Say it's log of 6 divided by 3. That would be 10 minus 12 log 2. Okay. And I think, yeah, that's still going to be a positive number. Make sure of that. Yep, that's positive, and it's like it was 1.68 something, so I guess that looks reasonable based on the diagram. Doesn't look unreasonable. Find the value of the integral from 3 to infinity of g of x squared. Now we're back to improper integrals. G was 12 over x plus 3. Okay, 12 over x plus 3. Okay, so it's that whole thing squared, so that's going to be 144 divided by x plus 3 squared. Okay, and I might actually, for the purposes of anti-differentiation, write that as 144 times x plus 3 to the negative 2 power. All right, so now this is equivalent to the limit as the upper bound approaches positive infinity, integral from 3 to b of g of x squared was 144x plus 3 to the negative 2. I'm just going to go over here and do my antiderivative work. Okay, and now I'm ready to let x be b and 3. Because I need at least 2 limits. Just to make sure I'm getting my credit even in the strictest scenario, right? So b plus 3 minus negative 144 over 3 plus 3. Oh, I bet that does. Yeah, that is going to divide because it's divisible by 3 and it's even. It's 144 divided by 6, but it's so obvious, but let's see. Well, maybe I'll start by dividing 144 by 2 and getting 72 divided by 3. That would be 24. 24 times 6, definitely 144. Okay, so that's going to be... That's a 24. This fraction is going to 0, so that would be 24. Then let h of x equal x f prime of x. What is h? Or what is the integral from 0 to 3 of h? Okay, hopefully you didn't think I was going to let you get out of here without doing any integration by parts. We're going to need to do at least one of those, and this would fit in perfectly. So I'm going to be thinking, in this case, u equals x, dv equals f prime of x dx. We've done these before. Okay, so I'm going to take the derivative of u, the antiderivative of dv. So remember that the integral of u dv, you might be about to forget, that's u times v minus the integral of v du. And I'm going to say, all right, this is going to be now, it's that, that's me, x f of x minus the integral of f of x dx. Okay, so from 0 to 3, this is going to be equal to x f of x 0 to 3 minus the integral from 0 to 3 of f, which I believe we already know. That was 10. Got that there, and yes, right there. Okay, so that'll be, whoops, equals 3f of 3 minus 0f of 0 minus 10. So I just need to figure out what f of 3 is. So f of 3 equals 2. So 6 minus 10 equals negative 4. Right, now number 16. At time t equals 1, an object starts at the origin and moves along the curve y equals sine of pi over 6x in such a way that its horizontal velocity is modeled by dx dt equals negative 1 over t squared. As t approaches infinity, the object approaches a point A and B. Find the values of A and B. Okay, well, I suppose we could use an improper integral, but I think what we should do is maybe try to just like model the x coordinate, you know, just like get x of t. Might be what y'all would think to do right here. I don't know, it doesn't really matter, but maybe I'll show you the other way as well. Okay, so I'm going to say, in this case, x of t should probably equal, okay, an antiderivative for this would be negative t to the negative 1 plus some constant. But it said at time t equals 1, the object starts at the origin. So that means that x of 1 equals 0. So it'll be 0 equals negative, any power of 1 is 1 plus c, so c equals 1. So x of t equals negative t to the negative 1 plus 1. Or 1 minus 1 over t, however you like it. And then as t approaches infinity, the object approaches a point A and B. Well, A, I think, is just going to be the limit of x of t, right? Whatever happens to the x-coordinate as t approaches infinity, so it looks like A is approaching 1. And so, yeah, I'm just going to say, okay, limit, I might even rewrite this. And then I'm going to say, well, I'm going to consider the limit as t approaches infinity of x of t. That's going to equal 1. Okay, that gives me a equals 1. And then I know y equals the sine of pi over 6x, and, you know, x is approaching 1, so I think I'm going to be approaching sine of pi over 6. And make myself a little trig diagram. It's been a while. I can visualize it. But I don't know, if you can't, then you need to draw yourself a triangle. Okay, pi over 6 is one of the shorter 30, 60, 90 triangles, and so the sine, the vertical leg, is going to be the shorter one, and that's going to be 1/2. Okay, so that's going to be a half, and that gives me that b is half. Right, now we're on to, I think, the last page. So region A is the base of a solid. For this solid, cross sections taken perpendicular to the y-axis have area given by 1 over the cubed root of y. Find the volume of the solid. Okay, so A is kind of a weird looking region. Oh, man, I thought I was going to have y'all find the area of region A on this homework. I'm going to do that all the same, because that was something that we really struggled to do, I don't know, sometime last semester, at least this year. So what I'm going to do, I'm going to say, okay, if we're taking cross sections perpendicular to the y-axis and they're just giving me the area formula, I need to just believe them. So that's going to be the integral of y to the negative 1/3 dy, y going from 0 to 2. Okay, this is an improper integral, and I don't think you'd necessarily be expected to recognize that. I think The ones that you're expected to recognize as improper are the ones that are obviously probably like going to infinity or they're unbounded or whatever. And but this one is improper, so I'm gonna rewrite it as a limit. And for a homework, I think that's no big deal. So integral from zero, not 0 to 2, a to 2. I was wondering if we are gonna have one of these on the homework because hadn't yet. Okay, antiderivative for y to the negative 1/3 with respect to y. I'd add 1 to the power and divide by the new power. So say I'm ready to plug in a. So 3/2 a to the 2/3 minus 3/2 of, wait, no, 2 is the upper bound. That's a pretty easy fix. 3/2 of a to the 2/3, and as a approaches 0, 0 to the 2/3 is still going to be 0 because the cube root of 0 exists. We can square 0, no big deal there. And so that's going to be 3/2 of 2 to the 2/3 power. And then finding the area of region B or showing that it doesn't exist. This one I found surprising. Okay, so I remember when I found the problem. So B is going to be top minus bottom. I do need to figure out which one's which, though. Okay, on bottom, I can see x equals 3. That looks like 2/3 to me. And when x equals 3, 12 over 10 would be a little bit bigger than 1. Okay, yeah, so top is going to be the more interesting fraction. So just use the diagram I made electronically and say, all right, top minus bottom is going to be 4x over 1 plus x squared minus 2 over x. Okay, and that's what we're just going to be integrating from. It looks like the intersection point, which I'm feeling like it's going to be x equals 1 based on the diagram. Let's plug in x equals 1. 2 over 1, 4 over 2, yes, great, okay. 1 to infinity. Okay, so this is an improper integral, so I'm going to turn it into a limit. Okay, I'll just ignore the fact that I called it region B. They probably wouldn't do that to you. Okay, so 4x over 1 plus x squared minus 2 over x. Okay, the plan here is I'm going to be doing a u substitution on that first fraction. Kind of right there. So I'm going to say u equals 1 plus x squared. But I'm just going to do the antiderivative because I don't need to do it on the 2 minus x. And I'm just going to figure out what the antiderivative is and then bring it back. Just again, it's an improper integral. So with u substitution, I don't recommend changing the bounds. Otherwise, I do recommend changing the bounds, but not for an improper integral. The way they are on the free response, at least. So du is 2x dx. I have 4x dx. It's going to be 2 du. Alright, so 4x over 1 plus x squared. That was like basically 2 over u. Okay, so that's going to be 2 log absolute value of u. Alright, so let's see, when I anti-differentiate that, okay, yeah, so now I'm going to break out there and say that the antiderivative of 4x over 1 plus x squared minus 2 over x, that's going to be 2 log 1 plus x squared minus 2 log x. plus c. Okay, yeah, there we go. Now, I think if I want b to approach infinity, I would be wise to induce a fraction, so I'm going to actually apply the log property there over x and add c. All right, so now this is going to be, got it in view at least, b approaches infinity, okay, top minus bottom, plug in b. I thought this was supposed to exist. I was supposed to. Don't see why it would because it's bigger on bottom by 1. Okay, I'm gonna go with this thing diverges. Okay, 1 plus b squared over b. You could say b plus 1 over b, same thing, doesn't really matter. I'm gonna go ahead and say that this doesn't exist anyway, so, but when I plug in 1, I get 1 plus 1 is 2 over 1. So natural log 2, that limit fails to exist, and I see the limit integral diverges or whatever. I'm gonna go back and check that. I don't know, I couldn't find the original problem. If I'm wrong, you let me know. So suppose f is twice differentiable with f of 0 is 3, f of 1 is 7, and the limit of f is 12. Using the substitutions u equals 1 over x and du is negative 1 over x squared dx, find the value of this integral. Okay, this is going to be a u substitution. So I'm going to do the work off to the side. They even told me what the substitution was. I don't have negative 1 over x squared dx. I have positive 1 over x squared dx. So I just think that's going to be the negative integral of f prime of u du equals negative f of u plus c. Okay. So I need to write two integrals. This is going to equal the limit as the upper bound goes towards infinity of the integral from 1 to b. I'm not going to change to u here. That would be tempting, but then these bounds would be wrong. And that was something I really wanted to point out. That's I'm just going to leave it at that. I just really want to point out that if I make the substitution to u and I don't change those bounds, then I'm definitely going to lose some credit in a free response scenario. Okay, so I'm just going to stick to what they told me. F prime of 1 over x divided by x squared dx. And now I've got an antiderivative. That's negative f of, pardon me, forgot to substitute back 1 over x because those 1 and b are going to be x values. So this is going to be the limit as b approaches infinity of f of 1 over b minus negative f of 1 over 1. Okay, as b approaches infinity, that's negative f of 0 plus f of 1. So that's negative 3 plus 7 equals 4. Okay, just be very careful with our limit statements and our bounds of integration and everything on these because people are watching. Please don't free response. So the last one is, maybe this is the one that I had initially thought was going to diverge, but is going to approach finite value. So I've got this weird looking curve and x equals k, and as k approaches 0, does the area of R approach a finite value? So I'm going to look at the limit as k approaches 0 from the positive side, because it said k was greater than 0. So, from k to 1 over the square root of e, I'm going to also call that e to the negative 1/2 of f of x equals log of x to the negative 2 power times x to the negative 1 dx. And yeah, that's going to be u substitution because the derivative of natural log x is 1 over x, and that's that x to the negative 1. All right, so I think it would be even more obvious if I wrote it like that. So, because this one is going to be a perfect match, u equals 1 over x. No, it doesn't. U x du equals 1 over x dx. There we go. So I'm integrating u to the negative 2 du. Okay, and u was log x. Okay, so there, I've got it. And still bad news, right? I'm still taking... Oh. Wait, negative 1 over log x. That does exist. How do I even show that, though? Oh, man. This is tricky. So, I think what I would do, I hate to appeal to log properties all the time when I said that was something we didn't really need anymore. I'm going to say that's 1 over negative log x, which is equivalent at the very bottom of the PDF. So log of 1 over x, that still might be giving me, still trying to divide by 0. It's, no matter what, this is bad. I'm either plugging 0 into log or I'm trying to divide by 0. This is not approaching a finite value. Okay, so I need to write the limit that fails to exist. Okay, so I could just go back to the original one, negative 1 over log x. Negative 1 over log of e to the negative 1/2, which would have been a negative half. Minus negative 1 over natural log of k. Still feel like as k approaches 0 from the positive side, natural log of k approaches negative infinity, so that fraction is going to go 0. Man, I'm back and forth on this one. I will say that these maybe go a little bit beyond scope of the ones, or like this one, not number 19. Number 19 is definitely in scope of AP Calculus. It was this one. 18 and 20 are both a little bit of an extension because they require that kind of intensive log property analysis. I'm gonna go with because I remember this being, when I checked it on Desmos, this is going to be 1 over negative 1/2 is 2, and then there's going to be a 0 over there. Something, well, I guess is, also, you can just think about it as just step by step. The limit does exist. If you need support on that, I guess come talk to me, but I will also tell you it's not that big of a deal, especially if you're good with the ones up here, the first 8, and then nice ones after that. Okay, so that's all for this video. Thanks for watching.